Hi, my name is Guillermo Baigorria, and this tutorial is to show you how to use the Geospatial and Temporal weather generator. In this video, I show you how to generate the data. You go to the Data Generation tab, and from there you upload the file you just created, in this case the 7 weather station observed DBF file. Immediately the software recognizes the period of time you use for the analysis and put in this window all the weather station you used it in the perfect order we need for the generation. Then you select the methods for generating temperature. We have 3 methods implemented: lag zero, first order, Markov, and cross correlation. Please check the documentation with the installation package to decide which one are the difference within them. Next, for the outputs, you select the period of years you want to run. In this case, we'll run only 1 year as an example. This is really trivial to the software. However, for the users from the running agriculture and environmental models, they need daily data and they need the dates. So it's very important this period of time. For temperature, you select the number of iterations for generating temperatures. You set the maximum standard deviation for generating the random numbers, and the maximum root mean square error for selecting the ensemble member you want to use. What it means, you select for every day of generating data, you in this case produce 10 ensemble members. From the 10, at the end we select the one which produce the lowest root mean square error. However, if we are at the time we are generating the data, if one of the ensemble members produce a root mean square error lower than this threshold, then we stop the number of iterations and we select directly this number. For rainfall, we have rainfall events and we have rainfall amounts. In rainfall, again, we set the number of iterations. Let's put a lower number for our example, and the maximum root mean square error. The amount of iterations for rainfall amounts, so let's put a lower number also only for purposes of the tutorial. And this is an important feature of the software. It allows an extra n% relative to the historical record of each weather station. What it means, if you are in hindcast mode, you don't want to produce values larger than the historical records. Okay, so you can put 0 here or 10 or 20 depending on what you want. However, if you are producing climate change scenarios for downscaling, then you can let different thresholds beyond the historical record, even though you can go 1000% extra to the historical record for at each weather station. In this moment, let's work with hindcast mode, so we just established 10%. Let's generate the data. In this processing window, it shows you that it is generating rainfall events for the year 2010, rainfall amounts for 2010, temperatures, and it's already finished. Geospatial data generated, we are done. Output formats, we are producing single WTD files, or we can also produce yearly WTG files, these 2 formats. And this window, this control files, is for developers, those who wants to check the performance of all the software step by step, can produce a larger number of files, looking for the different intermediate files that looking for the different errors or performance of the different equations in the process. Thank you.